All right, 7.3, modeling data using exponential functions. Okay, so we have a chart and we're going to put it into our calculator. Okay, so do you remember how to do this? We go to Stat, Edit, and then we have our list. So I'm going to clear down, go up, clear down. Okay, so 1871, 1881, 1891, 1901, 1911, 1921, 1931, 1941, 1951, 1961, and 1971. So it typed in. And then in L2, I'm going to write the population, 2.44, 3.23, 3.74, 5.42, 7.22, 8.8, 10.38, 11.51, 14.01, 18.24, and 21.57. Okay, so I got all my data typed in. Okay, so now we're going to use a scatter plot. So I'm going to go into that. So second, so I want that scat plot, so second function y equals, and I'm going to turn it enter. I'm going to turn it on by an enter, and that's the type I want. Okay, I'm going to hit zoom. Just to change my table, I'm going to go to zoom stat number 9. And there it is. So you can see a little bit of an exponential curve, right? Okay, so now we want to figure out what the equation is. So stat, calculate, and this time it's going to be an exponential regression. And there's our equation. Hold on a second. I'm just going to double check my... Okay. So we're going to go to y equals, get whatever you have out of there. I'm going to go to vars statistics, and I'm going to put my regular equation in there. So it puts that in there for me. I'm going to get rid of the scatter. Actually, no, I'll keep that in there so that you can see how the line is going to fit. So it fits that nicely, the data. Okay. Now I am going to actually get that scatter plot out of there. So we just have our line. We know that that line fits. Okay. Assume the population growth continues at the same rate to 2011. Estimate the population in 2011. Okay, so window, I'm just going to make sure I'm going past 2011. Okay, and then we're going to trace, and then I'm going to hit 2011. And we get 54.15 million. Okay, so now we're going to go to number 2. Alright, what I'm going to do, since I can't on number 2 type in all of those things, I'm just going to find the averages. So I'm going to calculate the average of those 3 in each. So the average of those 3. So get each average. Average of the 3 trials. Okay, so now I'm going to use this and this as my L1 and my L2. So go to Stat, Edit, clear that other stuff out of there, up, clear, down. Okay, so 0, 5, 10, 20, 30, 40 goes into L1. L2 is 77.667, 67.667, 60.333, 44.333, 33, and 24.667. Okay, so now I'm going to turn my stat plot back on. Okay, and I'm also going to zoom 9. Okay, so that's what my points look like, and I can see a curve exponentially, and it's a decreasing one, so I know my base is going to be a fraction. Okay, so I'm going to go to Stat, Calculate, and I'm going to get to an exponential. Stat, Calculate, Exponential. And here is my equation. Okay, so if you want, I'm not sure if it makes you write it down, 78.68 times 0.97 to the x. That's kind of what it would look like then. Okay, so what I'm going to do now is I'm going to put it in here. So I'm going to go to VARS Statistics and over to the equation and enter a regular equation, and it puts it in there for me. So you can see how that line is going to match up well with our data. Okay, so now I'm just going to go actually get my plot off because I don't want those points in there anymore. We know that it matched up well. Okay, so there's the line that I'm working with, or the exponential regression. Okay, so determine the equation. Estimate the temperature of the water 15 minutes after the trial begins. Okay, so I'm going to go trace 15, and there is. So at 15, the temperature is 51 degrees Celsius. Okay, estimate when the water reached a temperature of 30. So 30 is the Y I'd be looking for. So obviously you could scroll down like that to get an estimate, but if you want to know exactly, you actually go here to your Y equals and put in to the second equation 30. So there's the height of 30, so if I want to know exactly when this curve was 30, I'm going to calculate and then go to intersection. First curve, second curve, enter, and it would take 33.4 minutes. Okay, and then we call this a decaying function when it is a decreasing exponential function when you are going. So a function that goes like this is called a decaying function.